Hello. So it's April, and I'm going to try and do this month's TMiP Animation Generation Collaboration task, which is to draw a cube being folded up from a net. And once again, I'm going to do it in TikZ. So let's start by making a template, a blank LaTeX file. Document class article. Okay, and if I then build that like so, I can open that and I have a PDF to play with. Okay, and so just like I did last month, I'm going to resize this PDF using geometry. Let's have no margins. Let's not come out to do it. Let's look at last month's. Paper width and paper height. Okay, and those values will do for now. I might want to come back and change those paper sizes. Whoops. But for now, that'll do. Okay, so let's put a no indent here and then begin TikZ picture. And once again, I'm going to put my hacks in here to make the TikZ picture look much nicer. So I do line width is 1 point, line cap equals round, line join equals round. And also different to last time, I'm going to define X, Y, and Z, which we have to put inside curly brackets here because they're going to have commas inside them. So TikZ lets you define what the first coordinate and second coordinate and third coordinate of the point you use inside a TikZ picture mean. So I'm going to make Z be 0 centimeters, 1 centimeter, so Z goes straight upwards. I'm going to make Y, wait, these are both going to, so X is going to go down 0.5 centimeter, Y is going to go up 0.5 centimeter, and then import math. If we've got a, so I'm trying to do an isometric drawing, so I'm trying to do a right angle triangle. So I've worked out that if the z-axis goes straight upwards, I want the x and y to be on the other two sides of an equilateral triangle. And so if you go in the x direction, you go 0.5 units up, and you're going to have to go that amount across. So your hypotenuse is 1, your height here is 1/2, so I've got to do 1 squared, take away 1/2 squared, square rooted, you get 0.866. That feels about right. So if these go up 0.866 centimeters and 0.866 centimeters. And if we draw from 0, 0 to 1, 0 to 1, 1 to 0, 1 and cycle to go back to where we started. We get an error because I've misspelled TikZ. So we get a a square, but it's an isometrically drawn square. And just to show it definitely is what we want, let's draw a cube. So if we go 0, 0 to 0, 0, 1, in fact, just to make it clearer, I think if you leave off the Z coordinate, it treats it as 0, but it would be clearer if we just do 3D coordinates everywhere. Like so. Let's just get rid of hello. And let's put more vertical lines in. In fact, it would be simpler just to make these pluses, then like that. We're getting a cube, and then the last face is going to be that, but with ones on the end. So that is going to be what the cube looks like that we're ultimately aiming for, although I'm going to reposition it so we've got space for our net to fold up. So shortly we'll work out what size we want our animation to be, but first I'm going to draw... let's start by drawing the net flat in the XY plane. And for the net I'm going to choose the kind of cross-shaped net because I think that is going to be the simplest one to animate. Although I think you could do all of them in a very similar way, but this is going to be the simplest one to imagine, I think. And I'm going to do the square in the middle, 4 squares around it, and then 2 squares in the direction going kind of away from the camera so that the folding up goes kind of behind the image and doesn't cover up everything, so you can kind of see what's going on better. So let's get rid of these and just go back to having 1 square. And off that square, I'm going to go from, what do I draw again? 0 to 0, 2, 0. I think that will go that way. No, that's not the way I was expecting. So... Okay. So I was imagining 0, 0, 0. I was imagining going in the negative x direction is that way. There we go. That's what I was expecting. In fact, I want to go to negative 2, 0, negative 2, 1, and then back to 0, 1, 0. So that will do the part of the net there. Then I have to do another line on that. To split that into 2 squares, that's going to be -1, 0, 0, line to -1, 1, 0. And we get 3 squares going there. And now we just need to put 3 more squares around that central square. So I'm going to go for 0, 1, 0 to 0, 2, 0, 1, 2, 0, 1, 1, 0. So that should put a square to the right. Yep. Then we'll put a square here. In fact, we carry on from 1, 1, 0. That's kind of neat. And then we go for 2, 1, 0. 2, 0, 0, 1, 0, 0. I think the last one will then be 1, 0, 0 goes to 1, negative 1, 0 goes to 0, negative 1, 0 goes to 0, 0, 0. Okay, so that is our flat net, and already I can see I'm going to need to make the paper wider, so let's do that. Let's make it 5 centimeters wide. That looks good. Maybe 4. No, 4 is what I had before. 4.5. That looks reasonable, but also as this folds up, it's going to... what's the tallest it's... Okay, so the tallest this image is going to be is when, after some folding, you get the four faces around it kind of upright, and then the face at the back kind of going 2 units upwards. So if I draw that face at the back upwards as well, so that was this face here. Let's make a copy of that, and instead of going up to -2 on the X here, it's going to end up going 2 on the Y. It's going to look like that, and I think this is the largest the picture needs to be. So if I kind of crop the image to this shape, then it's going to look right. It's going to not go off the edge when we're animating it. So for that, in here I can do a clip. I'm going to have to put units in here, because if I don't put units in the coordinates here, it will treat them as X being diagonal and Y being diagonal, whereas if I put units, it will actually treat them as that direction and that direction. So if I go from 0, 0, 0 to 4 centimeters, 4 centimeters, that's going to look very wrong. Oh, I've got the semicolon. In fact, it's easier to see what you're doing if I do a big fill red from -10 centimeters, rectangle 10 centimeters, 10 centimeters. So then you can see I'm cropping the red rather than just cropping the white background. And now we can adjust this. So X needs to go further across. Oh, that's Y. Oh, that needs to go further up anyway. 2.8, is that enough? Too much, 2.5, 2.6. Okay, that's got a little bit of breathing space around the image. And the X, let's see if that is also 2.6. No, 2.8. 2.7 should be enough. And it should start from maybe -2. -1.8. Oh, that's nice because it adds to 3.8, which is, no, it doesn't. It adds to, so the width of that is now 4.5, which is what I've used as paper width, so that's convenient. So I imagine then if the paper height is 1.2, if I put -1, oh, the paper height is 3.8, if I put -1.2 here, that should match, and we get the whole image. So let's take that horrible red background off. And that is the size that we want our paper, but now I can delete that one there. So now the folding up is going to fit in the frame, and I can now animate this, and it's not going to have to kind of keep moving as we animate it. Right, so now I need to make an animation frame. So let's do a new command. Draw frame. Let's give it 1 input. And let's do that there. And let's just put that before the begin document to keep our document tidy. And then I will do a draw frame 0. And that will draw it there. And then if I do a draw frame, let's make the input go from 0 to 1. So if I do a draw frame 0.5 and a draw frame 1, then 0.5 should be kind of halfway folded and 1 should be the whole way folded. Although I'm going to do for this first draw frame, I'm going to be folding it so that the kind of 2 backward square is still pointing upwards. So we get a cube with one of the squares pointing upwards still, and then we're going to second animation just to kind of close the lid. So the draw frame 1 is still going to be the end animation, then we'll just make a second animation for that part. So now what we're going to do is the angle, let's put a comment for this, the angle which I want to lift all these faces up is going to be number 1 times pi over 2, because pi over 2 is 90 degrees, so the angle is going to be that. So if I use, in fact I think LaTeX uses degrees, so if we do that #1 times 90, we're going to be doing that angle there. So now I think it's as simple as them inside these here. If that's cos of this times 90, I don't need to put brackets there, like that. Similarly here, that times cos hash 1 times 90. Cos because essentially we want the square face to trace out, like the point at the end of it kind of traces out a circle, so it makes sense we're using sine and cos. And I'm doing cos as the one where it starts, because when cos of 0 is 1, and then when it gets to the top, cos of 90 is 0, and for the other part we do sine. So when it reaches the end, we want the z component to be the one that becomes 1. So let's put 2 times sine in there, and now it looks like we've got it, except in this second frame here we're going off the edge, so let's just recrop that a bit. It's obviously the diagonal is slightly taller than the full height of it, so we'll just add a bit to the cropping. Let's make paper height 3.9, and let's make this 2.7, and we can adjust that again later if we want to, but that should now mean there. So we've got the 3 frames where this kind of back thing is folding up. We just need to now move all of the other edges to do the same. So let's do the middle line first, because currently the midline is just kind of left behind. So we'll move that one up, hash 1 times 90. I don't need to write -1 times. Minus cos hash 1 times 90. Oh, interesting. I think we don't even need the minus, because minus of cos is the same as cos. So we could actually have left out a lot of minuses here, but it will be less confusing if I look back at this later if I leave those minuses in. And here we get sine of hash 1 times 90. There we go. So now that middle line is following as we go. It looks like those aren't square in the middle, but I think that's just an optical illusion because of the isometricness of it. We'll see if it looks reasonable as we make it. And now we need to do exactly the same trick on all of these other ones. So this 2 should be 1 plus cos. I'm going to copy and paste that because I'm going to be typing this an awful lot. And this is 1 plus cos. And the z is always going to be sine of that. So the reason these all need curly brackets around them, because otherwise LaTeX gets confused by too many, by the round brackets inside the round brackets. It's not good at inferring what goes where. So the trick is that you put curly brackets around all of these, so that LaTeX knows that these round brackets are inside the coordinate and not the end of the coordinate. Right, let's just check that worked. The second one did, the third one didn't. Let's undo that and have another look. That looks right to me. One plus cos. Correct. So why is it looking weird in the second one? Okay, we'll revisit in a minute. Let's do the last one. So that's minus cos of that. Minus cos of that. Sine of that. Sine of that. Whoops, that's not where the curly brackets go. Oh, okay, right. It's because when it's halfway up, the faces are folded so that they form a straight line when you draw isometrically. So if I change that from 0.5 to 0.3, it should be clear what's going on. Yeah, they're folding up correctly. It's just 0.5 is the point when they just happen to, by an optical illusion, look like they're a straight line. But that is definitely working. What I do need to do now, though, is when it gets to this later stage here, we want to fill these whites so that you can't see through them, so it looks actually like a cube rather than a wireframe folding together. So to do that, I'm going to make sure, I think I've accidentally done it actually. I need to order everything I've drawn so that the furthest away stuff is drawn first and the other stuff is drawn on top, and then I can just put a white fill inside everything, and that will behave as you'd expect. And then it would look as you'd expect, because it would draw. Yeah, if you draw the furthest away stuff first and then draw the forward stuff with a white background, that will kind of hide the stuff behind and it'll look correct. I've just noticed before I do that this still isn't tall enough, so let's add another 2mm to that. So hopefully we're not going to go off the edge now. So I'm going to replace this draw with draw fill equals white, and then put a semicolon here and copy this to each line. And we'll see what this looks like if I don't change anything. Cycle. Oops. Okay, that looks pretty good. So it looks like I have actually drawn the stuff that's in front last, kind of accidentally done it in order, so that when it folds up, you now don't see the other bits through the bits you were doing. Draw frame, draw another frame. Let's make the second command now, which is going to kind of fold the lid down. So for this part, let's make a copy of this, and let's make a new command called draw another frame. And for this one, it's actually going to be a simpler animation, because all we want to do is move one part of it. So we can start by actually removing a lot of this. And we need to go 0, 0, 0. In fact, let's put this on top. And let's draw it in red for now, just so I can see it overlaying what we had before. So 0, 0, 0 to 1, 0, 0. That's the line we want. To 1, 1, 0. To 1, 1, 1. To 1, 0, 1, 1, 0, 0, 1, 2, 0, 0, 1, back to where we started. There's one part of it. Then we need another part. We need to go from 1, 0, 0 to 1, 0, 1. Let's draw that vertical in, and then we need to go from 1, 0, 1 to 1, 0, 2. We'll draw that line, although that's slightly upsetting because that's not the real coordinates. We've done it too far forwards. If it's going straight up, we actually want that line backwards, so I'm just going to correct the coordinates there. Because it actually should be like that, which will look identical, but is more correct, except going up to 1 rather than go up to 2. There we go. And then we've got something to that same point, to something else. They're both at Z is 1. This one is 0, 0, 1, and that one over there is 1, 1, 1. Put those in. There we go. So we've drawn the cube. that's open that we can see, and now we need to do the lid separately because the lid now needs to be on top of it and hide what's inside the box as it closes. So we're going to draw fill equals white from 0, 0, 1 to 0, 0, 2 to, so that's up to over here, which is 0, 1, 2 to 0, 1, 1. And let's draw that in green, just so I can see it's definitely drawing something new. Correct. Right. And then we need to cycle so it draws the bottom line rather than partially covering up the bottom line to make it look thin. Okay, so that's what the box looks like. So now I can delete the old code, delete all the colours in here, so that's just fill as white, that doesn't need a colour. There we go, and now we need to animate this closing, so let's do some more frames here. So 0, 0 0.3, 0 0.61. Again, we're going to use a scale from 0 to 1 so we can watch this closing. So let's look at those middle two so that we can check this is right. And so in this one here is where it started up with, so I think that's cos of that. And this one's 1 plus cos of that. And once it reaches the bottom, it's going to be going in the x direction, so there's going to be a sine here. Like that. And that looks like it's going to make a reasonable animation, I think. So we start with a net, it folds up like this, and then the lid folds down to make a cube. And I guess if we want to, we can then animate it going backwards again. But let's make this animation now. So I'm just going to remind myself of what we did last month, because I want the same code as last month to make the convert to MP4. So there's the Python file we want. So if I copy convert to MP4 into this folder, we now have a convert to MP4 thing. So we're going to make frames to PDF, we're going to convert them to images, and then we're going to make a MP4 of those. So this is exactly the same code. We can use exactly the same conversion code as we did last month. So that is good. We now need to make a thing like we did last month, where we can make it one of those recursive functions that we made to draw this without having to copy and paste. Because essentially we now want to copy and paste this loads of times, slightly changing this number every time. But we can write a recursive function to do that. I'm going to kind of copy that from last month rather than writing it again. Let's just zoom out a bit so I can see. Here we go. This was the code to do that. So let's just copy that into here. Right, so let's remind myself what that was doing. It was okay, so last time we were going from 0 to 90. Well, let's do that. That would be simpler, I guess. 30, 60. It's going to be easier if we work in whole numbers, so let's just refactor to do whole numbers. And if I then can replace hash 1 times 90 with just hash 1, and everything gets a lot simpler. Let's just check that still looks sensible. Yep, that still looks like the animation we're trying to make. So then, where is this? Here it is. Here is the animation counter, and so the backwards slash animation, what it did is if okay, so it made I made a counter called animation, and I draw the frame for 4 times that, so I did a frame every 4 degrees. That seems sensible again. Let's see what that looks like. And if it was equal to 90 degrees, it stopped. If it wasn't equal to 90 degrees, it added 1 to the counter and then runs this again, so that it keeps running this until it hits 90. So if I put animation here, and yeah, need the if then package. Then we have a very broken animation. And that's because we're going past 90 degrees, because what it's doing here is drawing frame 4 times this number, and this number is going all the way up to 90. What we could do, actually, we can do the whole animation in one go. We can do if then else. No, I'm overcomplicating it. Let's just do it the other way. Let's undo that. So I was thinking I could make it do all the first bit, the second bit, and then the unfolding in one function, but it's going to be too complicated, so let's just do this. So this is going to hit 90. 90 is not a multiple of 4, so that's actually going to be pretty horrible looking. Let's do 4.5 times the animation, because then if we do 90 divided by 4.5 here, once this number reaches 90 over 4.5, that's going to have hit the point where we want to stop animating this. And 90 divided by 4.5 is 20, because this is 2 times 45. 45 divided by 4.5 is 10, so it's 20, yeah. So let's see, yeah. So it animates, and then I haven't done the next bit. So what I can do now is I can make an animation 2. Animation 2. Yeah, LaTeX doesn't like using numbers in the names of things, so you have to use TWO rather than the character 2. So if I do that, and then here go animation 2, let's see if that works. So now it folds up and does nothing. That's because I've missed a 2 somewhere. Because there it's calling animation 2. Oops. Let's see, right. So it folds up and the lid falls down. That looks good. And now let's animate it going backwards, because then it will make a reversible animation, which will be quite nice. Have I got 2 frames where it... Yes, I've got 2 frames, because there's the last frame of... There's the last frame of the animation part 1 and the first frame of the animation part 2 are the same frame. So I should... let's just start the step counter at... No. This is easy. 19. Just delete the last frame for the animations. Right. Right, let's get rid of that one. replace 2 with 3. For animation 3, we want to do exactly this, but we want to do 90 minus that. So that it animates starting from 90 and then goes backwards. Let's see if that looks okay. So it closes, then it opens. In fact, we maybe want it to pause there for a minute and have some multiple frames here, because it's going to look it's a bit too quick that it opens back up again. So let's draw another frame 90. Let's put a few of them in so that it opens up, stays open for a bit, and then starts to close. It finishes, stops for a bit, and then opens up again. That's going to look better. Animation 3, animation 4. So let's make a fourth animation, which I'm going to copy the first one because it wants to be that one backwards now. Animation 4, 4, 4, and now this wants to be 90 minus. And then at the end, we'll copy this so that it stops on the opened up for a bit. Just get rid of those anothers. There we go. So now that should animate it folding up with the face still upwards, animate that face folding down, stop on the closed cube for a while, animation backwards of the top opening up, animation backwards of the rest of it opening up, and then stop on the net for a while, and then we can put that on repeat and it will be a nice looping video. So let's make that and make sure that it does actually do what we want it to. So it folds up, top goes in, pauses for a bit, opens up. Oh, and then we get to the end of the document. Wait. Oh, okay, right, I see what I've done here. It jumps from there to there. This should be the open net, so this should be animation frame 0. Okay, and that, okay, now it then stops at the open frame for a bit. So if I've done this right, our Python convert to MP4. Oh yeah, it should just work. If I make an image folder and do Python convert to MP4, it should be converting every frame into a PNG and then making a MP4, which it's done. Let's watch that again. It folds up, closes for a bit, opens up and folds back down. And that is my animation of a cube folding and unfolding from a net. So just like last month, I will put links in the description down below to the code for this on GitHub, which I'm going to just tidy up a bit and then put on GitHub, and also links to the final animation and a link to the playlist of other people that have made an animation. Thanks for watching.